Okay. Now this will give you a head start on the assignment that'll be due, I think, Thursday, which will be your introduction to logarithms. So next Thursday and the following Tuesday, you'll have a couple of assignments on logarithms, then apply them. Now it's very simple. I'm not going to try to motivate it. We'll do that next week when I prepare the thing, but we have a couple of rules. B to the A equals C is equivalent to log base B of C equals A. It's an inverse function relation. Okay, now you did see inverse functions back in chapter 1. So the logarithm to the base B is inverse to the B to the X function, okay? So that's one rule. If you have this, you can always write this. And if you have this, you can always write this. Okay. As long as you're careful about where things go. And that's really quite easy. People don't usually have any trouble with that. And I doubt that you will. The other rule is log base B of C is log of C over log of B. Which is the same as natural log of C over natural log of B. And that's the same as log base 2 of C divided by log base 2 of B. Now I'm kind of abbreviating it. The log base B of X function is inverse to B to the X. So it follows yeah, it's not a good place to draw that. Now I'm going to redraw it. Put my x-axis up a little higher. Put everything up a little higher. So here is your basic 2 to the X function. if you take the point -2, 1/4, and reverse the coordinates, you get a point on the graph of the inverse of this function. And that point would go about here. And I'm not using equal scales because of the constraint of board space, and I don't want to mess much with board space. If you invert the coordinates of this point, the point -1, 1/2, you get the point 1/2, -1. If you invert the coordinates of the y-intercept, you get the x-intercept. If you invert the coordinates of the point 1, 2, you get the point 2, 1. And if you invert the coordinates of the point 2, 4, you get the point 4, 2. Well, it doesn't exactly look like an inverse function because of the distorted scales. So the y equals x line would be like here. But it is the inverse function relationship. And I believe you've already drawn that a couple of times. And the function you get here is y equals log base 2 of x. These are inverse functions. Well, similarly, log base b of x is inverse to b to the x. Now, the log log is on your calculator. And your calculator is the only way that you're going to calculate log logs, okay, except for powers of b. Okay. Ln logs are natural logs, okay, inverse to the e to the x function. Now, since this has come up, we'll go ahead and talk about this. It's a fairly simple scheme, and I think you're going to have no problem with the material for the upcoming section, and nobody else is here, so I'm just talking to you, okay? If the whole class was here, I wouldn't be able to go any further than this. Okay, so let's see if I can do this here. Okay. Compound interest at 100%. Well, you're 1 plus r over n to the nt. At 100%, r is 1. 100% expressed as a decimal is just 1. I wrote it as 1.00 just to emphasize that. Could have just written 1 over n. And that's what I'm going to do in subsequent steps. And let's just write this now, 1 plus 1 over n to the nt is quantity 1 plus 1 over n raised to the n raised to the t power by the rules for exponents. Okay?
Yeah.
So P equals P naught times 1 plus 1 over n raised to the n raised to the t. Now, if you've done some problems with compound interest and you've let n get larger and larger, you find that you get diminishing returns. Okay? The bigger n gets, the less difference it makes to make n much bigger.
Mm-hmm.
As n goes to infinity, this 1 plus 1 over n to the n approaches the number e. We call it the Euler number.
Mm-hmm.
Arguably the most important number in mathematics. People might think that pi is the most important number in mathematics, and there's a good argument for that, but pi comes out of e in a way that you really don't want to know right now, okay?
Yep.
I could explain it, but to understand it, you really need second semester calculus with the Taylor series. And since you might never get there, it's not going to matter. Just take my word for it,
Sure.
okay? But it's very simple. Once, a second semester calculus student at this point of the semester should be able to understand that perfectly, okay? So as n goes to infinity, this goes to e, and e I need the 2 in front of this, and then a 0.71. There's my 1. But that's for the thing. Well, I'm just going to say E is approximately 2.71828. Okay. And if you go a little further, it looks like it repeats. And it does once, but then it never repeats again for a long time. And there's no repeating. It's an irrational number. The decimals never get into a repeating pattern or any other kind of pattern we can identify.
Mm-hmm.
Just goes on forever. Okay. It takes significantly higher mathematics and calculus to prove that.
Mm-hmm.
But you don't have to go that high. Undergraduate mathematics major can prove it. Okay. So you can take our word for it. Unless you want me to teach you 3 more years of mathematics tomorrow. Okay. So you don't. Yeah. And if you're suffering from insomnia, it might be a good cure. Okay. Now, so as you compound more and more often, that means n is the number of times you compound in a year.
Mm-hmm.
If you compound every month, n would be 12.
Mm-hmm.
Compound every week, n would be 52. Compound every day, n would be 365 and a quarter, roughly. Okay. And then usually you use 360 because the 5 and a quarter doesn't make any difference for any practical purpose, at least not in business. Okay. If you compound every hour, well, then n will be 365 and a quarter times 24, something up in the 70,000s. If you compound every second, it's about 31 million. Okay.
Mm-hmm.
And at that point, you might as well just use this. But at 31 million, you might not even get all those numbers.
Mm-hmm.
You probably would, but you wouldn't go too much further. I don't remember exactly where it cuts off. Anyhow, as n goes to infinity, and P goes to P naught e to the T.
Mm-hmm.
Okay, there's your definition of E. This would be continuous compounding. At 100% annual interest. Well, you're not going to get 100% annual interest. And if anybody offers it to you, get away from them as quickly as you can, because they're trying to do terrible things to your finances. Okay. Avoid anybody that offers you that unless we get into hyperinflation. Okay. And let's hope that doesn't happen. Okay. So we have continuous compounding at 100% annual interest. Here it is. P naught e to the RT is continuous compounding at annual rate R. Okay. Now you do just a little trick to what we've got up here.
Mm-hmm.
You put R here. Okay. And then you do what we call a change of variable, and you end up with an R here and end up with an RT. You don't want to know. Okay. It's not difficult.
Uh-huh.
We could take 30 minutes and you would understand it completely, but it's not worth the 30 minutes in a pre-calculus course. I think it is actually, because change of variable is kind of an important thing. But we're going to cut it off right there. You just take my word for that. And if you become skeptical enough, just ask me. We'll take 30 minutes and do it. Okay. Not hard. Just seems a little weird. Okay. Doesn't seem weird to me, but it would seem a little weird to you. So there's the bottom line. I don't think your textbook explains it.
Mm-hmm.
Textbooks used to explain it. Mm-hmm. Teaching at a lower level than we used to. But it's okay. Don't feel bad about it. If you understand this, it's good. Okay, so that's all about E.
Mm-hmm.
At least all you want to know about E. The special number, it's the limit of this expression, and it's about equal to this. And you have E to the T on your calculator. You have an E to the X button on your calculator, okay?
Mm-hmm.
So you can always calculate E to anything, to many, many decimal places. All right. Now, why are we doing this? Because it came up in your problem, that's why.
Mm-hmm.
So let's just look at your problem with that background. This last problem, you have P of T equals 350 E to the 0.17 T. And your question was, when does P of T exceed 1170? Now, your best way of estimating that would be start plugging in numbers for T until you get something a little bigger than 1170 and something a little less than 1170, and then keep doing trial and error using your calculator.
Mm-hmm.
Okay. Alternatively, you could use a graphing calculator and graph this thing and do an estimate. Even better, you can do your own graph and estimate it. Not going to get into that now, but we probably will see that a little bit later, just to completely understand logarithms and so forth. But if you want to really solve this,
mm-hmm.
You can use trial and error, you can use a graph, and so forth. So, well, you write the equation, 350 e to the 0.17 t equals 1170.
Mm-hmm.
So e to the 0.17 t equals 1170 divided by 350.
Mm-hmm.
Now using the rule I'll put up here, b to the a equals c means log base b of c equals a.
Mm-hmm.
So I'm going to just write that down. This is a b to the c equals a, where b equals c, b equals e, c equals 0.17 t,
Mm-hmm.
and a equals 1170 over 350. Okay?
Mm-hmm.
We write log base b of a equals, wait a minute, have I got that right? Yeah, c. Okay? And that becomes log base b, b being e, so that's log base e of a, which is your 1170 over 350 equals c, which is your 0.17 t. Now notice that your 0.17 t was here stuck in the exponent.
Mm-hmm.
We now have it down here where all we got to do to solve for t is divide both sides by 0.17. So we can easily find t.
Mm-hmm.
And the reason we can easily find t is you have the log key on your calculator.
Mm-hmm.
Okay? Now, log base e is what we mean by the natural log.
Mm-hmm.
So we have 0.17 t equals the natural log. And we want to write it as natural log because you have a natural log key on your calculator or any computer algebra system or a online calculator. So we have natural log of 1170 over 350. So t equals a natural log of 1170 over 350 divided by 0.17. And now you can take your calculator. Now I can tell you that if this was e, then this natural log would be 1. If I divide 1170 by 350, I get something a little over 3 because 3 times 350 is 10,050. That's 1,050.
Mm-hmm.
So this is about 3 1/3.
Mm-hmm.
So I think that the natural log of 3 1/3 ought to be about 1.2. Just using my knowledge of numbers and so forth. Okay. And 1.2 over 0.17 is pretty close to maybe 0.7 because 0.7, 7 times 17 is 119. Now something is wrong here. Yeah, this is approximately equal to 7. Okay. If you take your calculator and calculate this, you should get something pretty close then to 7.
Okay.
Okay. And 17% interest. Would have a doubling time of about 4 years, a little more than 4 years. 7 might be a little high. Say it's between 6 and 7. So you punch that in your calculator and see how my brain's working today. But we already kind of know the answer to that. So there's no big point in it. Okay, make sense?
Yeah.
Okay. Okay, well, that's pretty much the rest of chapter 4, so you can just quit. No, can't do that. There's more to do. But that's a big chunk of it right there.
Mm-hmm.
If you understand that, everything else ought to be pretty easy to understand. And since you're not having much difficulty, I think that might well be the case. Okay. Well, that took us outside of the topic for next time, but it also gives us context for what we're going to do for next time. Now, I want to go back to my open math because I could jumble up the topics for the next section with the topics of this section. So I want to keep myself honest. My scroll is not working very fast. And that's because there's not all that much to scroll. Okay. Basically looking at the characteristics of graphs of exponential functions. And from what we've already done and what you've already done for homework, I think you're going to understand that the graph of y equals ab to the x is going to look like this. And let's assume that b is greater than 1. We'll do b less than 1 as well. That just kind of turns things backwards. Okay. You know that the y-intercept is 0a. And that's very straightforward because the y-intercept occurs when x is 0 and any number to the 0 is 1. Okay, so you have a times 1, so your y-intercept has to be 0a. Okay, and the other thing is, if you come out here to where x equals 1, well, if x equals 1, y is a times b. Okay, so you have the point on the graph above x equals 1, and that would be the point 1, A times B. If you have these 2 points and understand exponential functions, then you know that the graph is going to look something like this. And you know that just from the 2 points. And the fact that the graph has exactly the same shape
Mhm.
as the basic exponential function y equals 2 to the x. So as we did last time, if you wanted to start with the graph of y equals 2 to the x, and I'm not going to go to the trouble to draw it really carefully, but here is an unlabeled 2 to the x graph. Then this point is going to be 0a. And then find the horizontal line y equals a times b. So let's say step 1, you have this unlabeled graph. Step 2, you label this point 0a. Step 3, you sketch a line y equals a times b, so that this is b times as far from the x-axis as this is.
Mhm.
Then here is x equals 1. So that this point is going to be 1 a times b.
Mhm.
So now, if you're given a graph of an exponential function, step 1, estimate A. Okay, so the book is going to give you picture of a function. It's going to go through the y-axis at some point. Estimate the coordinates of that point. Okay? Often it'll be some whole number or half number, whatever. But one way or another, you can estimate this. Then you have 1 on the x-axis. So step 2, draw the line x equals 1. Now, in the problems you have through My Open Math, you have a grid. So you'll have the line x equals 1. But if you didn't have it, you'd have to draw it. So I'll say step 2, which is unnecessary if the line is already drawn, but if it isn't, you want to draw it. Of course, you can't draw it on the computer screen, but you can visualize it, okay? And in your problems, it'll always be there. Okay, you draw the line x equals 1. Step 3. You identify the point (1a times b), which will coincidentally be on the vertical line where x equals 1, obviously. And then 4. Estimate AB, which would be the coordinates of this point. And then 5. Calculate AB over A. To get your estimate of B. And step 6. The formula is y equals a times b to the x. Now, you probably didn't need me to number these steps for you. You probably could have figured all that out yourself. But just in case, there are some steps. And of course, other people might be watching this video and they might really need the steps. Okay? And you might find that the steps just make it quicker to learn it. That's I trust you to do whatever's best, because that seems to be what you're doing throughout the course. Okay? Now, that's your formula for this kind of an exponential function. It can get just a little trickier. Yeah, I got this side of the board. Let's say that you have a graph. It looks like this. Okay. Now, this is an exponential function for b less than 1. If b is less than 1, and of course greater than 0, because it's not even defined if b is less than 0 or equal to 0. But that's going to give you a decreasing exponential. Okay. And let's just say that there's an obvious line that this thing approaches, and that will be the case for the problems in your book. There's going to be a grid, and there's going to be some grid line, some horizontal grid line that you'll be able to pretty well guess is your asymptote. Okay? So identify your horizontal asymptote. Okay? Or estimate it if you don't think it's there on the graph someplace. Okay? Then step 2, which I'll put in color here, you want to vertically shift the graph so the asymptote is the x-axis. Well, it should be obvious that your vertical shift is from wherever the asymptote is to the x-axis, which is where the asymptote is for a basic exponential function, okay? For just an unadored exponential function. So here's our vertical shift. You just take all these points and raise them up the distance of that vertical shift. And you get your vertically shifted function. Identify A. Well, this becomes the point 0A. Use the line x equals 1 to estimate AB. So here's the line where x equals 1. Here's the point on the graph. Here's the line y equals AB. And this point would be then the point zero AB. You want to estimate B. Which you estimate by dividing your estimate of AB by your estimate of A. Right? Y equals AB to the X. Using estimates of A and B. Okay, so everything we've done in orange has been with your vertically shifted graph.
Mm-hmm.
So you vertically shift back to your original graph. To get Y equals AB to the X minus K. I'll put K in orange. Your vertical shift is what we're going to mean by K. K is the vertical shift you needed to get from here to here, to get from the white graph to the orange graph.
Mm-hmm.
So to get from the orange graph to the white graph, you're going to shift by negative K.
Mm-hmm.
And that's from step 2. Now, if you understand both of these examples, you'll have no trouble with the homework. Now, your book and your videos are going to give you compatible procedures and examples. Okay? They're saying the same thing. I've said it in a way that's maybe a little different than the way they say it, but that's always good as long as I'm saying it to somebody who's capable of comparing the two ways. Okay? And that I expect is your case. So it's really fairly simple. You just take this graph, you move it up here, you make your estimates, you get your function, then you do a vertical shift and move it back down.
Mm-hmm.
Now, there's a little common sense involved here. You could also potentially think of shifting your X and Y axis down to where the origin is here,
Mm-hmm.
doing your estimates, which would be equivalent. But I'll leave it to you to sort that out. Okay?
Okay.
Again, I think you'll be fine with this. Now there are other questions about long run behavior and so forth. You're not gonna, yeah, I'd be extraordinarily surprised if you have any trouble at all with that. Graphs look reasonably straightforward. By that, I mean, if you have a graph where the asymptote is not the x-axis,
Mhm.
it's usually pretty obvious what line they intend for the asymptote. Thing will approach some grid line. And the version I see right here, and your version will probably be different. But one of the grid lines is the line y equals 2. Another is y equals -6. You'll have no trouble. Well, we've done about a week and a half's worth of stuff. If you understand it, as I expect that you pretty much do,
Yeah.
and once you work it through, you're going to understand it perfectly.
Mhm.
I think you'll be in very good shape. I'm not inclined to talk about anything else today because that's enough for you to
That is.
fill your mind with. And remember the stuff I did in the first half of the class just comes off of the fact that they gave you a function and you asked about it with the natural logs and stuff. So whatever we did in the first half is your fault. You have to accept responsibility for it. But you don't really have to know it until we get to the later sections.
Sure.
Okay?
Yep.
So I don't foresee anything that's going to give you any serious trouble, at least for a while. And I don't think anything's going to give you serious trouble at all.
Sounds.
Keep working the way you are.
Thank you. I tried to work hard.
Well, you do. You have the proper discipline. You're more mature than most students coming right out of high school. And that's always a big deal. I have another class where the only person who's doing it is doing it because he doesn't have time, but he's got a full-time job and kids, so he does it anyway. And it, same thing. He does what's necessary, gets it to me
Right.
for the deadline, and it's all very good.
Yeah.
He also appears to have a pretty good background, and you actually have a pretty good background, even though it's been a while. Same thing for him.
Mhm.
I do have current students who, are quite bright,
Mhm.
who appear to be doing okay. And many of them are in much harder courses than this one.
Mhm.
But there are people who got their trigonometries high school sophomores. You have to be pretty bright for somebody to put you in a trigonometry class when you're a sophomore. My grandson got put into a pre-calculus class when he was a high school freshman.
Nice.
Yeah, well, he's doing real well right now in electrical engineering at Virginia Tech. So he's a bright kid, and not the brightest kid I've ever seen because brightness goes way up, but bright enough. Probably smarter than I am, which doesn't take much.
Wow. I hope he has a good sense of humor. That's important.
Yeah, well, he'd better if he's going to be my grandson. Uh, I hope he does. Okay, well, I'm going to leave it at that.
Thank
Uh,
you. All right. I will see you on Tuesday. And yeah, we'll get some work done before that.
I know you will. So uh,
Thank
very
you.
good. Keep up the great work. See you Tuesday.
Will do. I'll see you on Tuesday. Bye-bye.
Bye bye.